So when we're given the coordinates to a solution and we're asked to determine if it is a solution, we plug it into both equations. But if we're given a system and we're asked to solve it, we have three options. We can solve that system by graphing, which is what we're going to learn in the rest of 5.1. You can solve it by substitution, which is something that we'll cover in section 5.2, or by the addition method, which is something we will cover in 5.3. Depending on when it was when you first took algebra, you may have learned the addition method as the elimination method. The instructions say solve each system by graphing if there's no solution or an infinite number of solutions. So state, use set notation to express solution sets. So let's look at these instructions just a little bit closer. We're going to use the graphing method to solve the solution. If there's no solution or an infinite number of solutions, this is where on the previous page we talked about the possibility that either the lines cross and you get one solution, 1 point, or they are parallel lines, which would give you no solution, no point that they have in common. Or it's an infinite number of solutions, and that's if it's the same line graphed on top of each other. And that would be the infinite number of solutions, the actual line. And then use set notation to express solution sets. Should have been exposed to set notation in Math 60. If not, here's your chance to get caught up on that. Again, anything that you find you should know at this point, but you're still a little shaky on, get help right away. Make a note of it. Bring that to your help resource or to class, and we'll make sure that you get the extra help that you need, whether it's through individual tutoring or some additional practice problems. So solving by graphing means that we're going to draw the two lines on the same graph and see where they intersect. Okay, so graphing means that you draw lines on the same graph and look for the point of intersection. Okay. Let's review one of the ways to graph a line. Again, this is from Math 60. When you have the equation, we'll go ahead and look for the intercepts. So we make a table. X, Y, we'll let x equal 0 and then y equals 0. When you put in x equals 0 for equation 1, you would get 0 plus 2y equals 2. That means y would have to be 1. When you put in 0 for y, again still equation 1, x plus 2 times 0 equals 2. X would have to be 2. And so our points that we would plot for equation 1 would be the point 0, 1 and the point 2, 0. And we would connect that line. And that's graphing using intercepts. We do the same method for equation 2. Any method you would like to use for graphing is fine. We're reviewing intercepts right now. We'll use a different method on the next example. So intercepts means you let x equals 0, y equals 0, plug that in and find out what you get. Equation number 2 here, using 0 for x, we get 0 minus y equals 2. Y would have to be a negative 2. Plugging into the second equation, again, y equals 0, you would get x minus 0 equals 2. X would have to be 2. And at this point, when you plot these two on the graph, you'll notice that you do find the intersection right away. These two match. That point is on both lines. Let's go, if we didn't notice that, let's go ahead and just graph it. 0, negative 2, 2, 0. There it is right there. That's the point of intersection. Go ahead and draw the line to finish the graph. is the solution to the system. And because we want to write our answer in set notation, we just basically take that coordinate 2, 0 and put it in the, if you've had me before, you've heard me say it, French, they're not really French braces. They're the fancy little brackets. Parentheses, brackets, braces. These are the braces. Okay. And that's what you use for set notation.